Active learning. Background. Machine learning often needs large labeled datasets, but in areas like healthcare or autonomous vehicles, labeling data can be expensive and time-consuming. Doctors must analyze MRI scans, and self-driving systems need expert reviews of complex driving scenarios. Active learning addresses these challenges by focusing labeling efforts on the most informative samples, saving time and costs. What is active learning? Think about how humans learn to recognize objects. You don't need to see every possible example of a cat to distinguish it from a dog. You learn from a few representative samples, especially the ones that highlight important differences. Active learning applies this idea to machine learning by minimizing labeling costs and letting the model pick which data points it needs labeled. Rather than labeling every sample, we concentrate on those that the model finds most uncertain or confusing, leading to high accuracy without exhaustive labeling. How does it work? Start small. Train an initial model on a small label set. Find uncertainty. From a larger unlabeled pool, we use the trained model to identify samples where the model is least confident. Label selectively. Have experts label these uncertain samples. Retrain. Incorporate the newly labeled data and use a new dataset to train a new model. Repeat. Continue step 2 until the desired accuracy is met or the labeling budget runs out. Current research focuses on step 2, specifically how to find uncertainty to get the biggest performance gain in each cycle. What are some use cases? Active learning is highly effective in medical imaging. Doctors label only borderline scans, cutting down on unnecessary work. Self-driving cars prioritizes unusual pedestrian or traffic scenarios that are rare yet crucial. Large-scale image databases. Companies label only the images the model struggles with, slashing costs. Active learning's potential. Active learning offers significant advantages in terms of cost savings, as it targets only the most valuable data points for labeling. By continuously focusing on the toughest or most ambiguous samples, models learn faster and often reach high accuracy levels with far fewer labels. This selective approach also makes active learning far more scalable than traditional methods, since it avoids a need to label every single data sample, particularly useful when dealing with massive data sets. Don't forget to like, subscribe, and hit that notification bell to stay updated with more tech insights. Drop your questions in the comments below. We'd love to hear your thoughts.